Number 1 says divide. So we have 1/3 divided by 6. One way to solve that is to use the reciprocal. So my first number stays the same. I change my dividing into multiplying, and I flip-flop my numerator and denominator to find the reciprocal, which becomes 1/6. Now to solve, 1 times 1 is 1, 3 times 6 is 18. My answer is 1/18. Another way to solve is to find a common denominator. So I have 6/1 divided by 1/3. I can change 6/1 into something over 3. 1 times 3 is 3, 6 times 3 is 18. Now I ignore my denominators and divide my numerators. So we have 18 divided by 1 equals 18. Number 2 says Lindsay's bookcase is 5 1/3 feet long, 1 1/4 feet wide, and 6 1/12 feet tall. How much space does the floor of the bookshelf take up? So if I'm looking at the floor, I'm just looking at the bottom part. I know it gives the volume and it gives the height, but we don't actually need that information since we're just looking for the area of what the floor takes up, which is a 2D space. So my number model is going to be 5 1/3 times 1 1/4. In order to solve that, you can either use improper fractions or the area model. So for this one, I'm going to use improper fractions. 5 times 3 is 15, plus 1 is 16. My denominator stays the same. Times 1 times 4 is 4, plus 1 is 5, 5/4. Now I multiply my numerators and I multiply my denominators. 3 times 4 is 12, and then we have to do 16 times 5. 5 times 6 is 30. 5 times 1 is 5, plus 3 is 80. So now I have 80/12. 12 goes in to 80 6 times, with 8 left over. My denominator stays the same, so my answer is 6 8/12 feet squared. Number 3 says Ed used 1 1/4 dishes of paint on a project. Each dish holds 3/5 fluid ounces of paint. How many fluid ounces did he use? So if he used 1 1/4 dish, and each dish held 3/5, we have to multiply by 3/5. We'll say equals P for paint. So again, I can use the area model or improper fractions. So for this one, I'll use the area model. I have to split my whole number in my fraction, and then leave 3/5 here. 1 times 3/5 is 3/5. 3/5 times 1/4 is 3/20, and now I need to add them together. So 3/5 plus 3/20, I can make both of my denominators into 20 since we need a common denominator to add. 5 times 4 is 20, 3 times 4 is 12. My denominator stays 20. 12 plus 3 is 15. So my answer is 15/20 fluid ounces. Number 4 says multiply. So for my first one, 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. Move on to my 8. Since it's in my tens place, I need my 0. 8 times 3 is 24, carry the 2. 8 times 2 is 16, plus 2, 18, add together. 2 plus 0 is 2, 9 plus 4 is 13, 8 plus 1 is 9, 1 plus 0 is 1. I have 1, 2 places behind the decimal, so my decimal goes right there. My answer is 19 32/100. For the next one, 7 times 3 is 21, carry the 2. 7 times 6 is 42, plus 2 is 44. 7 times 5 is 35, plus 4 is 39. Moving on to the tens, add my 0. 4 times 3 is 12, carry the 1. 4 times 6 is 24, plus 1 is 25. 4 times 5 is 20 plus 2 is 22. Moving on to the last one, since it's 0, all of them are going to be 0, so we can just leave it. Now add together. 1 plus 0 is 1, 4 plus 2 is 6, 9 plus 5 is 14, 1 plus 3 plus 2 is 6, 2 plus 0 is 2. So I have 1, 2, 3 places, 1, 2, 3 places. My answer is 26 and 461 thousandths. In the last one, number 5 says, how is multiplying decimals similar to multiplying whole numbers? How is it different? So again, multiplying decimals is similar because you can multiply the decimals as if they were whole numbers, meaning you just ignore those decimal points. It's different because you have to figure out where to put the decimal point when you are done. So you can do that either by counting how many places are behind the decimal before you multiply, or you can do it by estimating and then putting that decimal point where it makes the most sense. So make sure you talk about how they are the same and how they are different in your answer.